In this lecture, we will see what are the drawbacks of difference amplifier and how to remove such drawbacks in the modified circuit. So, first of all, we should know what is difference amplifier. Difference amplifier is also known as subtractor. If you want to subtract two voltage signals in the operation amplifier, then it will be known as difference amplifier. So, the circuit of difference amplifier is drawn like this. This is resistance R1. This is feedback resistor R3. Here voltage is V1. Now this is resistance R2. Here is voltage V2 and this is resistance R4. First of all, we should know how to calculate V0. So here two voltages are connected. So we can use superposition theorem. Okay. Superposition theorem states that at one instant only one source is applicable in the circuit. So in case 1, I am considering voltage V1. Considering V1 and second voltage V2 must be grounded. Okay. Now, if V1 is considering V2 is grounded, the circuit will be like this. This is R1. This is voltage V1. We can see. This is voltage R3. Suppose this is output voltage V01. Here is positive. This is voltage R2 and this is voltage R4. So V2 is grounded. It means we can set at 0 volt and this is already at 0 volt. So it has no significance. So these resistors has no significance because here is no voltage source at non-inverting terminal. This is an ideal operation amplifier. It means here is 0 ampere current. Here is 0 ampere current because op-amp has infinite input impedance. If infinite input impedance means impedance is the ratio of input voltage to the input current. And it is applicable only when current is 0. Now, this is branch 1, I1. This is branch 2, current I2. And because this is 0 volt, 0 ampere, and here is no source, so the potential at, suppose this is Y point, Vy must be equal to 0 volt. Now, question is, what is the value of X point, X node? So, using virtual ground, both nodes must be at same potential. So Vx must be equal to Vy and it is 0 volt. Now apply KCL at node X. Apply KCL at node X. So I1 is equal to I2. And what is the value of I1? Starting voltage. I1 is started from V1 and terminated at Vx, and Vx is having 0 volt. So V1 minus 0 upon R1 is equal to 0 minus V01 upon R 3. It is R3. Yes, yes. So V naught 1 is equal to minus R3 upon R1 into V1. I think all have been understood. Now case 2, considering V2 and V1 is grounded. V1 is grounded. Now we get modified circuit. This is negative R1. This is R3. Okay, this is grounded, positive. This is R2. This is R4. This is grounded, and this is V2. Now, what is the value of this node Y? Can anyone explain? The value of potential at Vy must be equal to R4 V2 upon R2 plus R4. Okay, and at this node X, using virtual ground, Vx must be equal to Vy, and it is R4 V2 upon R2 plus R4. Now this is branch 1, current I3. This is branch 2, current I4. So KCL at node X gives I3 is equal to I4. Okay, and we can get, then suppose this is V naught 2. V naught 2 is equal to 1 plus Rf upon R 1 plus R3 upon R1 into Vx or Vy. So V naught 2 is equal to 1 plus R3 upon R1, चूंकि Vx Vy is equal to Vx, and Vy R4 V2 upon R4 plus R2. If we combine, this is equation number 2 and this is equation number 1. If we combine, then we can get V naught is equal to minus R3 upon R1 V1 plus R1 plus R3 upon R1 into R4 upon R4 plus R2 into V2. If we consider R4